Hey guys, welcome to AlgoYogi, and the next problem that we are going to solve is merge two binary trees. So let's go to the problem and read the description. You're given two binary trees, root 1 and root 2. Now imagine that when you put one of them to cover up the other. Basically, so if you look here in this example, here this tree and this one, if you put one on top of another, then the result will be this. Just the values combined, and if either of them had those nodes, it will simply be just appended into our final tree. So let's change the view and see how this is being done. And so this is what I was saying. This is our root 1 and this is our root 2. If we put this on top of this, then these two values will basically on this level, they will combine and give us this. Then on this level and this level, this will combine with this and give here 4, and this will combine with 2 and give 5. Or maybe let's just do the color combo here. That will be fun. So these combine and give here, and these no, sorry, my bad. These, they combine and give us 4, and then here 5 doesn't have anything on the root 2. This is root 1 and this is root 2. So this will just simply append itself. It doesn't have to add any value. So I think you guys can process now. And the way we will be solving is using recursion, iterating over both the binary tree and just simply combining their values if they exist. If either of them exists, just return that and append it. The entire subtree, you don't have to like process that, you don't have to like go down in it, and just return that. Okay, okay, let's write the solution here. Okay, let's focus on this area. Now I'll create a helper function. Let's call it merge bt. That's a binary tree that's going to take root 1 and root 2. So here we're going to have like some base condition, that is checking if root 1 and 2 both are none. So root 1 is none and root 2 is none. If they're both none, then we're just returning none. Okay, elif either of them have some value, so they're gonna come down to this, or then whatever is not none, that's what we return. So we return root 1 if root 2 equals none, else we return root 2. Then finally, we will create a root using tree node. And some people like to just, add those values into root 1 itself, but let's just do it in a clean way also, so that we know what we are doing. So root will be root 1.val plus root 2.val. So at this point, they both exist, right? Root 1 exists, root 2 exists. What do we want to do now? We want to append the left. What will be the left? Whatever will come from left side, left subtree of both the tree, which is root 1's left and root 2's left. And the same thing we're going to do on the right. Okay, right side. This is just doing the same thing again and again. Now we just, it's okay, right? Then we return the root, and finally we return the same function, not this, our merge bt, which is basically will return the final root. So I hope you guys understand why I'm just returning this, and this should give us the answer. So it calls on these two root, but when it's going inside, this root is created, which will be a new node, new root this, but here this is assigning this left subtree, this is assigning the work to this function again. Just go down on the left side of both these trees, root 1 and root 2, and then bring me a constructed root, left subroot, and that's how recursively it will go down and create the left side and right side, and then our root will have its left and right subtrees, and then it will just come back as a proper root. So that's it. Okay, let's try to run and submit it. So if I'm running it, okay, so something is off. Okay, yeah, root. Cool. This passes the test. You can see. Let's submit it. Awesome. Let's talk about the time complexity. That will be basically 2n, which is also n, and space complexity would be big of h. Awesome. Height of the tree. Usually in binary or BST it's log n, but here could be just in a proper binary tree. But in worst case, I think this could be just n itself, if both trees were just like left child, or right. So it becomes like a linear data structure, which is like linked list, but containing that next pointer as left or right, and the other side doesn't exist at all. Okay, let's go back to our AlgoYogi and mark this problem solved. See you guys later. Bye bye.